moving on to the empirical rule, one of my favorites. According to the empirical rule, if a distribution is roughly bell-shaped, then approximately. So here, keyword. So we have to have a bell-shaped distribution for the empirical rule to work. So within one standard deviation of the mean, so here's the mean, one standard deviation. So you added a standard deviation and you subtracted. That covers 68% of the data. What percent lies within 2 standard deviations? So now to your mean, you're going to add 2 standard deviations and then subtract 2 standard deviations from your mean. And that range will give you 95% of the data. And then 3 will give you 99.7%. And then always know that underneath this curve, it's always 100%. So directly, if we drew a line and everything to the left, this would be 50%. And then everything to the right would be 50%. So let's determine the percentage of students who have IQ scores within 3 standard deviations of the mean according to the empirical rule. So 3 standard deviations, that would be 99.7%. Determine the percentage of students who have IQ scores between 67.8 and 132.2 according to the empirical rule. Okay, now we have our data, so you're going to have to plug this into your calculator and figure out the mean and standard deviation. Okay, notice this is for a sample. These symbols are for population. So this can be used for sample data. X bar in place of mu, and S in place of sigma. So let's figure out what our X bar is and our S for this data below, these 100 scores. So you're going to go to Stat, Edit. Just a little note on how to clear this. If you go up to the actual list and hit Clear, and hit Enter, it'll clear the whole list for you. Clear and Enter. Okay, I'm going to pause this video while I type in all 100 values, and you can do the same. Okay, now I have the data in. So I want to find the mean and the standard deviation. It was in list 1. So the mean is 100.03. This is a sample, so we're going to look at S, not sigma. That's 16.07. 100.03, 16.07. If you did not get these answers, recheck your data. You might have had a typo. There are 100, so it is definitely possible. So what I would do right away then is just fill in these values so it's easier to see. So the mean was 100.03. Now add the standard deviation one time, so that's 116.1. Then add it again. And then add it one more time. Now do the reverse. On the left hand side, now subtract. So you get 83.96, 67.9, and 51.8. So determine the percentage of students who have IQ scores between 67.8 and 132. So 67.8 to 132. So we're looking at this range. So that's 95%. Now let's figure the actual percentage of students. So how many are between 67.8 and 132? Since there are 100 and we're going to be somewhere around 95, I'm going to just count how many are not in there and subtract it from 100. So, and these are in order if you go down. So we have 2 there and these last 2. So 4 out of 100 are outside of that range. So that means 96% actually have this score. So this does a great representation. We're very, very close. Okay. According to the empirical rule, what percentage of students have IQ scores between 116.1 and 148.3? So 116.1 is right here to 148.2 or 3, so close enough. So these two numbers. So 15.85%. And then E. So up above, what data lies in 68%? That is 83.96 to 116.1. 95 is between 67.9 to 132.2. And then 51.8 to 148.2. So if we wanted to do inferential statistics, remember that means we're taking our information from our sample and pushing it to the population. Inferential statistic needs to tell us how confident we are and the range. So we can say that 99.7% of the data lies between 51.8 and 148.2 for the IQ. If you have any questions, please email me or post to the discussion board. Thank you.